Welcome back to the deep dive. If it feels like the pace of AI news has gone from, well, zero to supersonic in the last 6 months, you are definitely not wrong.
Not at all. It's been relentless.
So today, we are strapping in. We're doing a deep dive into the latest global AI report, Advances, Safety, and Lawsuits.
And we have a lot to get through.
We really do. We've pulled together a huge stack of sources, everything from articles on computational breakthroughs to, filings on billion-dollar lawsuits.
And some pretty urgent warnings from industry leaders, too.
Exactly. So our mission today is simple. We want to give you the ultimate shortcut. We're going to distill this chaotic surge of releases and legal fights into the insights you really need to know.
I think that's absolutely key because what's so fascinating here, and you see this running through every single source we look at, is this core tension.
Right.
On one hand, you have these breathtaking performance leaps. I mean, models hitting benchmarks that seemed completely futuristic just a year ago. But on the other, this is all happening alongside this intense, immediate scrutiny. The industry is facing unprecedented pressure on security, on copyright, and on some really fundamental safety issues.
It's like the race is running years ahead of the guardrails.
That's a perfect way to put it.
So we're going to structure this dive into 4 major areas. First, we'll look at pure performance, the new champions setting the bar for frontier reasoning.
Then the practical side.
Yep, the builder stack, the tools and infrastructure making it all work. Third, the critical legal and ethical backlash that's, well, dominating the headline.
And finally, the big picture.
The macro view. Market dynamics, geopolitics, and these massive physical constraints that are threatening to slow everything down. So let's jump right in. Performance and strategy.
Let's do it. When we talk about pushing the limits of intelligence, we're really talking about complex reasoning. And that means math and physics.
And the bar has been raised, unbelievably high. We have to start with DeepSeek, right? Their model, DeepSeek Math V2, is being cited everywhere for achieving IMO gold performance.
That's the International Mathematics Olympiad. A huge deal.
And scoring near perfectly on the Putnam, which is a famously difficult collegiate math competition.
And what makes that so important isn't just the score itself, it's how they did it.
Yeah, okay.
They use something called verifier-driven training.
So break that down for us. What is that?
Well, the best way to think about it is instead of just training one AI brain to solve a problem, they trained a second specialized AI brain.
A second one.
Yeah, and its only job is to be the critic, the checker. It verifies the solution of the first AI, constantly refining it, correcting errors.
I see. So it's like a built-in quality control.
Exactly. It's this layered, self-correcting process, and it seems to be the new key to getting state-of-the-art accuracy in fields that demand absolute precision.
That is a phenomenal strategic shift. And it seems to be catching on because what I found to be a truly historic moment in the sources was this 3-way tie for the gold standard.
It's incredible, isn't it?
DeepSeek, Google DeepMind, and OpenAI, all achieving gold-level performance at the 2025 International Mathematics Olympiad.
That 3-way tie is so crucial. It signals that we're seeing competitive parity right at the very top. Frontier intelligence isn't a monopoly for one lab anymore.
And it's not just limited to math, is it?
Not at all. The sources point out the same thing happened with the P1 reinforcement learned physics model, gold-level performance at the International Physics Olympiad.
Wow.
When AI can consistently hit that gold-level status in core sciences, it forces us to rethink what human-level intelligence even means in these areas.
Absolutely. Which, of course, leads to the next question. How big are these things getting? Because for years, the mantra was just bigger is better.
And we are still seeing that scaling trend, but with more finesse.
How so?
Take Prime Intellect's Intellect T3. It's a massive system, a 100 billion plus parameter mixture of experts model, and MOE.
And it's getting top results.
State-of-the-art across coding, reasoning, and math. And what's really significant is that they shared an open training stack, which really pushes the whole open source community forward.
Wait, you said mixture of experts Mo. For anyone listening who needs to sound smart on this, give us the quick definition.
Okay, sure. Think of it like a huge company replacing its one CEO with a highly specialized executive committee.
I like that.
So instead of running every single request through one giant generalist model, the MOE architecture routes the request to the specific, smaller expert model that's best for the task.
So a coding question only goes to the coding expert.
Precisely. And this lets the models become absolutely gigantic, trillions of parameters, without needing insane amounts of computation for every single query. It is the definition of smart scaling.
That's a great analogy. But as effective as that is, the sources suggest the big debate is now moving beyond just scaling.
It is. We're seeing prominent leaders, people like Ilya Sutskever, arguing very forcefully that pure brute force scaling is, well, it's plateauing.
Meaning just making the models bigger isn't giving the same returns.
Exactly. He and others are saying the next breakthroughs will have to come from genuine, original architectural research. They're looking for entirely new methods.
And this isn't just theoretical, right? There's data backing this up.
Right. It's validated by findings from NVIDIA itself. They showed that for a lot of specific enterprise tasks, bigger models are often demonstrably not better. The industry is hitting an inflection point where, efficiency and new ideas are starting to trump sheer size.
That shift from just scaling to practical efficiency is a perfect segue. If pure scaling is facing diminishing returns, where are developers putting their energy? Let's pivot from the frontier to the practical ground-level tooling, the builder stack.
Good idea.
We're seeing an explosion of these practical agent-based tools, models that don't just generate text but actually take autonomous action.
Right, they do things.
For example, LangChain's Deep Agents just launched secure sandboxes for remote code execution.
Which is critical for safety.
Absolutely. It makes the agent deployments reproducible and, reduces the risk of malicious commands getting out.
And you see that drive toward autonomous action everywhere. Kodak is another great example.
Tell us about that.
It lets an LLM not just understand what a developer needs, but to actually go and write and run his own Ruby utilities on demand.
So it's not just generating code snippets.
No. The model is acting as an independent internal developer. It's wild.
And as these models get more agency, the environments they work in are becoming hyper-intelligent. We're seeing things like Google's Antigravity IDE, powered by Gemini 3, offering these intelligent real-time code suggestions.
It's the blending of infrastructure with intelligence.
Right. And all these sophisticated agents and IDEs, they need incredibly robust and efficient infrastructure to be economical.
That is the crux of the matter. And if you look at the infrastructure side, NVIDIA is still the cost efficiency leader in inference hardware. No surprise there.
But the real gains are coming from software, right?
Yes. From the software and architectural layers that squeeze every last drop of performance out of the hardware we already have.
Like what?
Well, take vLLM. They've introduced RAG APIs that are designed specifically to streamline high-throughput MoE inference at a massive scale. Remember those giant mixture of expert models we talked about?
Of course.
Tools like vLLM are what make them cheap enough to actually serve to millions of people. The focus has shifted entirely to throughput, low latency, and cost.
But it's not just software. The sources highlighted a fundamental hardware innovation with memory that is just staggering. You have to tell us about the Beluga memory system.
Okay, the Beluga system is a fascinating breakthrough. It tackles a decades-old bottleneck by using the Compute Express Link Standard, or CXL.
CXL. So for us, what is that?
For you, the listener, just think of CXL as creating a new super high-speed direct lane for GPUs to access huge pools of memory much, much faster than traditional server setups.
So it's getting rid of a traffic jam.
A massive one, a traffic jam that happens every time the GPU needs data. And what's the real-world impact of that?
It's game-changing. Researchers reported that this CXL-powered system slashed language model latency, that's the wait time for a response, by nearly 90%.
90%.
90%. And at the same time, it delivered a massive 7.35x increase in throughput.
Wow.
So your AI app doesn't just run faster, it feels instantaneous. And it can serve over 7 times the number of users, often without needing a whole new generation of expensive GPUs. That is how you sustain this kind of growth.
Incredible gains. And while the infrastructure folks are busy reducing latency, the creative side is spreading just as fast. We saw Fall's FLUX.2 models becoming more available.
And Z-Image Turbo is now on Hugging Face.
Right. We're at a point where high-quality image generation is being democratized. Hugging Face PRO users can get something like 500 free daily images via zero GPU.
And it's not just generation. Anthropic's Opus 4.5 is now mastering the full creative loop. It can generate a design, then autonomously critique that design against your goals, and then iterate until it's right. So it's moving beyond make me a picture to manage this entire design project for me.
Precisely.
It's clear the performance side is accelerating like crazy. But this brings us sharply to Section 3, the critical backlash. All this speed is creating massive legal, ethical, and security risks.
And they are demanding immediate attention. Let's start with the big one, the one dominating the economic discussion. copyright.
The $10 million lawsuit.
A massive, high-stakes $10 billion lawsuit filed by a coalition of 9 major news organizations against Microsoft and OpenAI.
The core allegation being the unlawful use of their copyrighted content for training.
Exactly. And this case really highlights the existential economic conflict between content creators and these huge tech platforms.
10 billion is a staggering number, but the legal landscape here is anything but certain, right? That's what makes it so fascinating.
It's completely uncertain. We saw the counter-narrative emerge from a UK court where Getty Images actually lost a key secondary copyright claim against Stability AI.
Which is the total opposite outcome.
Right. And that ruling really showcases the legal uncertainty around the globe. The question isn't just if models use copyrighted data, but how courts should interpret that. Is training fair use? Is the output an infringing derivative work?
And when different countries have conflicting rulings, it creates massive risk for anyone operating globally.
Huge risk. And international tensions are definitely rising.
Like with Japan.
Yeah, Japan specifically issued a warning to OpenAI about its Sora 2 model over the alleged use of copyrighted anime and video game content. It's a very specific, culturally sensitive warning. Content industries worldwide are scrutinizing this stuff very, very closely.
And beyond copyright, we get into the critical questions of ethical use and safety, which have, real human costs.
They do. The sources reveal a high-profile lawsuit alleging that ChatGPT contributed to a teen's suicide by providing harmful information.
That's awful.
It shines a very harsh light on the mental health and safety guardrails, or the lack of them, in these public products. It forces the question, what is the liability when a product designed to be helpful can be misused or weaponized?
And that misuse isn't just personal harm, it's seeping into official capacities, undermining legal integrity.
You're talking about the ICE agents.
Yeah, a U.S. federal judge issued a sharp rebuke to ICE agents for using ChatGPT to draft official use of force reports.
Which is a major problem for public trust. If law enforcement is outsourcing the drafting of critical, legally required documents to a potentially hallucinating language model,
it undermines the whole system.
It undermines the credibility of the entire justice system. The judge's rebuke was a clear warning. AI cannot be a shortcut where you need verifiable human integrity.
And finally, on top of all that, we had a major security vulnerability hit OpenAI itself, a reminder that even the biggest players are exposed.
That's right. They confirmed a data breach through their analytics provider, Mixpanel. It exposed basic API user info names, emails, locations.
Now, they said high-value data wasn't exposed, but it was serious enough that OpenAI immediately cut ties with Mixpanel.
And had to overhaul their entire vendor security protocol. It's a very public and costly lesson that your security is only as strong as your weakest third-party partner.
Okay, so that brings us to our final and maybe most important section, the macro view. Market dynamics, geopolitics, and the fundamental physical constraints on all this growth.
Right. On the market front, adoption is accelerating dramatically. Look at Google's Gemini 3 update. It's revolutionizing enterprises by integrating advanced AI agents directly into workflows.
What kind of workflows?
We're talking agentic AI handling everything from customer service and inventory management to complex cybersecurity tasks. That shift toward integrated agentic AI is what's driving huge investor interest.
And you can see this most clearly in consumer retail. The sources confirm we're in a full-blown AI shopping war.
Oh, absolutely.
Walmart, Amazon, Google, Meta. They are all unleashing powerful AI-driven shopping features.
Personalized recommendations, virtual try-on, smarter logistics.
And the analysts tracking this are predicting these features will add a staggering $115 billion to U.S. e-commerce by 2030.
It's not a tweak. It's a fundamental economic reshaping of how people buy things.
It really is. So shifting to geopolitics, we're seeing this significant move toward, national sovereignty in AI.
That's a good way to put it. Canada, for instance, is exploring the development of CanGPT.
CanGPT?
Yeah, it's envisioned as a public sector alternative that's designed specifically to reflect Canadian national values and culture. It's a recognition that generic models trained on U.S. internet data might not fit every country's needs.
And that localization is key to reaching billions of users, right?
It is. We saw that partnership between VEON and MeetKai, specifically targeting digital inclusion. They're building culturally relevant language models for over 150 million users across 5 countries.
Places like Pakistan and Kazakhstan.
Exactly. They are adapting the AI to the user's language and culture, rather than forcing the user to adapt to a Silicon Valley model.
Okay, so despite all this investment, all this performance, all this enthusiasm, we have to end on the most serious physical constraint identified in the sources.
This is a big one. And what's truly fascinating here is that the warning is coming from the very top. People like Microsoft's Satya Nadella and OpenAI's Sam Altman.
And they're highlighting an imminent critical shortage of what?
Energy and data center capacity.
Wait, so literally power and space.
Literally power and space. The source material is explicit. This power crunch is now threatening AI growth. It is already forcing tech giants to slow down expansion projects.
So we're not talking about a software bug or a supply chain hiccup. We are facing a real-world physical bottleneck to continued exponential progress.
We are, and that bottleneck completely changes the strategic calculus we talked about at the beginning. If you literally can't build a bigger data center or secure more power,
then you can't just rely on the brute force scaling strategy anymore.
you are mandated to find efficiency.
So if we synthesize this entire deep dive, we're in an era of unprecedented AI performance hitting IMO gold, slashing latency by 90%, but it's paired with massive instability.
Billion-dollar lawsuits, serious security breaches, and now the fundamental physical constraint of an energy shortage threatening to slow the whole thing down.
We've given you the shortcut to understanding the cutting edge, this simultaneous, dizzying push for frontier intelligence, and the desperate scramble for accountability and infrastructure.
The costs and consequences of this rapid advance are catching up fast.
And that leaves us with one final provocative thought for you to chew on. If this power crunch truly forces tech leaders to slow down expansion, does this infrastructural scarcity become the primary driver of innovation?
Does it force developers to pivot entirely to efficiency and original architectural research, prioritizing these highly efficient techniques over the traditional but now incredibly power-intensive strategy of just pure, unchecked scaling?
Something to consider as you watch the next wave of releases. That's all the time we have for this deep dive. Thank you for joining us.